Welcome to Mathematical Methods for Neurodivergent Students. First, what does it mean to be neurodivergent? Neurodivergent is an adjective that describes a person whose brain functions in a non-typical way. There are many types of neurodivergent conditions, including dyscalculia, dyslexia, autism spectrum disorder, ASD, dyspraxia or developmental coordination disorder, DCD, and attention deficit hyperactivity disorder, ADHD. Everyone learns in a different way. In this video, we will be looking at some of the difficulties neurodivergent learners may experience when studying maths, as well as some study techniques that might help when encountering a new topic or during revision. Now, not all of these techniques will work for everyone, and there is not enough time in this video to fully delve into all the methods you might want to try. However, I hope what this will show is that there is always a different way to tackle a problem, and that this video encourages you to seek out the methods that work for you. First, let's look at dyscalculia. Dyscalculia is a condition that makes it difficult to understand numbers, and many with dyscalculia struggle with what is called number sense. Number sense is made up of three main parts. Counting, the understanding that you can count by any number, in ones, twos, threes, or higher, and that this can be done both forwards and backwards. Wholes and parts. This is to do with understanding concepts such as fractions and how parts of an object or number can make up a whole. And proportional thinking, the ability to judge when there is more of one thing than another, and how many times bigger or smaller a number is compared to another number. Something that is especially difficult for people with dyscalculia is subitizing. Subitizing is the ability to look at a small number of objects and instantly recognize how many objects there are without needing to count. Many people may find it difficult to tell that there are 13 tokens on screen now without counting. But if you have dyscalculia, it may even be difficult to tell when there are just 2 tokens on screen without counting to check. Now let's look at dyslexia. Dyslexia mostly affects a person's ability to spell and read fluently. Some dyslexic learners may even experience visual disturbances or tracking problems, which can make the task of reading very difficult. Some key signs of dyslexia are difficulties with phonological awareness, which is the understanding of the different ways to process the individual sounds in words. Verbal memory, this is how well we can remember what we've heard, and many people with dyslexia may struggle with retaining information in their short and/or long-term memory. Visual and verbal processing speed, which is how long it takes to make sense of the information we see and hear. When studying maths, dyslexic learners may find it difficult to understand word problems, retain maths facts, compute maths mentally, and complete tasks as quickly as their peers. Now let's look at ASD. ASD stands for Autism Spectrum Disorder and encompasses a community of people with a wide range of support needs. Many people with ASD use the adjective autistic to describe themselves. Having ASD might affect many aspects of a student's learning, or it might appear to have very little impact. This is because autistic learners experience and communicate differently to non-autistic learners, and there is no one way to describe the features of ASD without excluding some part of the community. So, with that in mind, ASD might affect sensitivity to overstimulation when learning, interest and ability to focus on some subjects more than others, and ability to understand different forms of communication and teaching. But again, this is not true of all autistic learners. We'll now look at dyspraxia, also known as developmental coordination disorder. This condition causes difficulty with movements and carrying out tasks that require coordination. If you have dyspraxia, you might experience difficulties with visual perception, the ability to process visual information. This makes it hard to maintain hand-eye coordination and track information on a page. Reduced spatial awareness, meaning it is difficult to perceive the position of your body relative to your surroundings. And visual sequential memory, which is the ability to remember the information we receive visually in the correct order. While studying maths, it may be challenging for learners with dyspraxia to distinguish between similar shapes or symbols, align calculations vertically, interpret graphs, and visualize maths such as number lines and nets of 3D shapes. Finally, we'll look at ADHD, or Attention Deficit Hyperactivity Disorder. This is a condition that makes it difficult to concentrate for long periods of time. If you have ADHD, you may feel restless and act impulsively, You may also have trouble sitting still and feel the need to fidget or get up and walk around. When studying maths, this can make it difficult to organize work and keep track of calculation steps. Having ADHD can also affect memory. This can cause problems when attempting to recall key facts and mathematical methods. So now that we have seen what parts of studying maths may be tricky for some neurodivergent learners, let's talk about some of the strategies that can help. Trouble with memory can be really challenging, so going the right way about revising is very important. Little and often is the key strategy. You are much more likely to remember things if you do a small amount of revision every day, instead of spending hours on one day and then leaving it for a week or more. Repeating the learning ensures that the information sticks in your long-term memory. Take lots of breaks when you are studying. This will help you stay focused for longer and help you remember more information. You are more likely to remember things if you link it to what you already know, or connect it to your interests. For instance, this might involve changing a word problem to be about tennis instead of chores. Making the information multisensory means it will be easier to remember. You could do this by using mnemonics, such as bid maps. This tells you the order in which to do operations: brackets, indices, division, multiplication, addition, and subtraction. We could also use a silly phrase to help us remember this, such as, Bob is doing more amazing somersaults. You could also make up a song or explain the concept to someone else to practice organizing the information and your thoughts about a topic. Another way is to use visual cues to remember information, such as drawing a picture or color coding to distinguish symbols. We can practice developing our number sense by playing around with numbers. By manipulating a problem and trying different methods, we might make lots of mistakes, but that is okay. We can learn a lot from this and start to spot patterns and connections that make it easier to solve problems. Some of the greatest discoveries have been made using trial and error. Concrete materials are great tools for developing number sense, as they give a physical representation of the maths you are trying to figure out. People use concrete materials to help them understand things all the time, and they should not be limited to primary school learning. Some examples of concrete materials are counters, 3D shapes, building blocks, and cuisinaire rods. Perhaps try experimenting with these materials and different methods to see how they can help you visualize the maths you are learning. We will now look further into using concrete materials in order to help us multiply and divide. The material we are using is called Napier's bones. Napier's bones are the strips we get by cutting a multiplication square into its columns, and as we read the strips, or bones, from top to bottom, they tell us the times tables of each of the numbers from 1 to 9. Napier's bones help us to more easily multiply and divide large numbers. Let's look at multiplication first. Say we want to multiply 427 by 6. We look at the bones 2, 4, and 7 and arrange them so that we have the number 427 at the top of the page. We are multiplying by 6, so this is the row we want to look at. We can write the numbers like this to see our calculation more easily. The diagonal lines in the squares indicate place value, and we are going to add along these diagonals in order to get our answer. We have 2 in the units diagonal, 2 plus 4 making 6 in the tens diagonal, 4 plus 1 making 5 in the hundreds diagonal, and 2 in our thousands diagonal. So we can now read off our answer as 2,562. Let's try another example. This time we want to multiply 318 by 47. We again line up the bones, this time making 318 at the top, but this time we need both the rows 4 and 7. We write our problem like this. The diagonals are just a little bit longer this time. Let's add them up. We have 6 in the units diagonal, but this time when we add up the tens diagonal, we get 14. As this is a 2-digit number, we have to do what is called carrying. We take the digits of 14 and write the 1 in the next diagonal, and the 4 as the total of the tens diagonal. So in the hundreds diagonal, we have 1, add 4, add 3, add the carried 1, which makes 9. Then 2 add 2 make 4 in the thousands diagonal, and there is 1 in the 10,000s diagonal. Again, we can read off our answer, 14,946. We'll now use Napier's bones for division. We're only going to be dividing by single-digit numbers in this video, but you can use Napier's bones to divide by bigger numbers and perform further calculations like finding fractions. As an extra challenge, you might want to look up these methods after watching the rest of the video. Let's try dividing 792 by 6. This time we just need the sixth bone. We draw ourselves a table, write 6 to the left and 792 underneath. We begin by writing 0 in the first triangle and looking at the number 07. We want to know what is the biggest multiple of 6 that is still less than 7. We do this by looking at the sixth bone. The answer is 6, so we write 6 in the next triangle. The column next to the sixth bone shows what we are multiplying by, and we want to write this at the top of our table. So as 6 is 1 times 6, we write 1 at the top. Next, we want to make sure the diagonals add up to the number below them. So as 6 add 1 is 7, we write 1 in the next triangle. Now we repeat. We have 19, so using the sixth bone, we find the biggest multiple of 6 that is still less than 19, which is 18. So we fill out the rest of the square to give us 18 by writing 8 in the next triangle. 18 is 6 multiplied by 3, so we write 3 at the top. We now need the diagonal to add up to 9, so we write 1 in the next triangle, as 8 up 1 is 9. Repeat one last time. We have 12, which is a multiple of 6, so we can write that straight into the table by putting 2 in the final triangle. 12 is 2 times 6, so we write 2 on the top. This diagonal already adds up to what we need, so there's no remainder this time, and we can read off the answer, 132. Let's try another example. 391 divided by 4. We take the fourth bone this time, and as before, write 0 in the first triangle. There is no multiple of 4 that is smaller than 3, so we also write 0 in the next triangle, and write 0 on top of the table. We need the diagonal to add up to 3, so we need a 3 in the next triangle. Now we have 39. On the fourth bone, the biggest multiple of 4 that is still less than 39 is 36. We write this into the table, and as 36 is 4 times 9, we write 9 at the top. For the diagonal, 9 is 6 at 3, so we write 3 in the next triangle. However, this causes a small change with the next step. We want the biggest multiple of 4 that is less than 31. This is 28. This means we need to cross out the 3 in order to write 28 in the box. As 28 is 4 times 7, we write 7 on top. But now the previous diagonal does not add up to 9. How do we solve this? Do you remember what we said about carrying in the multiplication section? If not, you might want to rewind to get a reminder. What we want to do is carry over a 1 into the next diagonal so that it completes both diagonals. To do this, we need to add a remainder triangle. To complete the diagonals, we need a 1 carried into the next diagonal and a 1 in this diagonal. In other words, this diagonal needs to add up to 11. 11 is 8 add 3, so we write 3 in the remainder column. We can now read the answer of 97 remainder 3. Thank you for watching. Whether Napier's bones is the right method for you or not, I hope that this video encourages you to seek out the methods that do work for you, because maths can be a both accessible and rewarding subject to study if we just seek out the right tools with which to teach and learn.